The idea of this is it should give you a better idea of what the central tendency is doing. So if you look at the screen, each one of these dots on the left-hand side in the circle represents a data point. In other words, it represents a number. Okay? Now, what you can do with this is you can literally drag one of these data points and place it onto the number line on the right. So in other words, you can choose the value of that data point. So for example, if I choose the value of that data point to be 13, okay? Now you can see underneath that I can see where the median and where the mean of that data set will lie. So then I can add more points to my data set. Okay, so say for example I want to add one at 4. Okay, and you can see how the mean and the median will change according to that. So can you have a play around with that? Can you just play around with putting different values at different positions? And can you, more importantly, look what happens to the mean, the median, and the mode as you change the shape of this data set? Does that make sense? Okay, so literally just drag and drop different points, change the shape of the data set, have a play around, and have a look at what happens to the mean, the median, and the mode for me. Yes, if you like, yeah. And you can see underneath it, you've got a histogram. Does that make sense? Yeah? So yeah, you're absolutely right. It's a dot plot because each dot represents a different value in the data set. And then underneath that, I've drawn a histogram.
My question on the x-axis, what is the value
on the y-axis, you've just got frequency. You've just got frequency at the moment, yeah? And on the x-axis, that's the value of your data points. So have a play around with that. Can I give you 5 minutes? Okay. Then I want you to report back to me. I want you to report what happens as you change the shape of the data set. What happens to the mean, the median, and the mode for me? Okay, so what do we reckon? What do we reckon? Has anybody noticed anything about the mean, median, and mode according to different shapes of distributions?
the same answer?
Okay, good. So if you didn't catch that, for well-behaved distributions, by the way, do you understand what I mean by distribution? Yeah, so this here would be a distribution. It's just simply the shape of my data set when I plot it, okay? So this here would be a distribution. It's how my data set, how my data points are presented on a grid, on a graph, okay? So yeah, so Mohanad, you said that for relatively well-behaved distributions, in other words, for symmetric distributions, where there's data points on the left and data points on the right, they're kind of, they're flipped over, there's a line of symmetry in them, then the mean, the median, and the mode are relatively similar. Okay, so I've drawn a symmetric distribution on the screen. Okay, I can even change the shape of the distribution, it would still be symmetric. So for example, I could put things up here as well. Let's maybe move a point there. Let's maybe move a point here. Let's maybe move a point, actually let's move some points over there as well. So I'm keeping the shape of the distribution relatively symmetric, okay? Are you happy that the mean, the median, the mode, so like that, okay? You're happy the median and the mean will always lie somewhere in the middle, okay? In this case, the mode is obviously, there's sort of, how many modes are there? There's 6 modes, okay? Just because I've got data sets which are equally height. But effectively, for symmetric distributions, the mean, the median, the mode are relatively well behaved. They lie somewhere in the middle, okay? Somewhere in the center, hence why we call it central tendency. But then what happens if I start to break that down? So let me go back to the distribution which I had at the very start, or something like the distribution I had at the start. Okay, let me get rid of some points. So here we go. I have got here, okay, a relatively well-behaved symmetric distribution on the left. Okay. Now what happens then if I start to make it look non-symmetric? By the way, if it's no longer symmetric, does anybody know what we call that? Begins with an S. We start to call it skewed. S-K-E-W-E-D. Okay? Start to call it skewed. So skewed effectively means that it's not symmetric. Okay? So if I start to introduce some points way out here, okay, start to introduce some points way out here. Do you see that? Okay. What happens to the measure of central tendency? So what happens to the mode? Does the mode change? No, the mode still stays relatively in the middle, presuming I've got one which is like a leader, okay, one which has a higher frequency. Does the median change? No, but what happens to the mean? What happens to the mean as I introduce this outlier? Absolutely. So the mean is almost following that outlier. Yeah? If you have an outlier in your data all the way over there, the mean will try and follow it. The mean will try and follow it. Okay? So the mode and the median will stay relatively towards the center, even if there's outliers there. But as soon as I start introducing those outliers, the mean will want to follow it. Okay? So that's one disadvantage of the mean. Don't always go for the mean all the time, because if you have outliers in your data, the mean will be skewed towards it. Okay? Yeah. So outliers in the data, the mean will be skewed towards it. Otherwise, it remains relatively towards the center. Does that make sense to everyone? Okay, so are you happy with when you might want to use mean, median versus mode? So just to recap, let me just write it on the board. Okay. In order for the mode to be a good measure of central tendency, what do we need?
Can you repeat the question?
In order for the mode to be a good measure of central tendency, what property do we need in our data set? Yeah, exactly. We only want one mode. So, for example, the data set that I've drawn on the screen, okay, there's one bar which has a lot of data points in. Okay, so therefore the mode will be okay here. The mode will be okay. So, in other words, you need ideally one value for the mode. You can get away with two, but as soon as you start getting 4 or 5 or 6 or 7 data sets for the mode, it starts to become a bit skewed. Okay, right. What about the median? Okay, were there any restrictions on the median? Sorry? Actually, it doesn't matter if it's symmetric, because you see this data point here, even though it's way out here, okay, the median won't necessarily get attracted towards it, okay? So the median will always be somewhere in the middle. So the median is usually a relatively good measure of central tendency, okay? But yeah, you are right, I can kind of see where you're coming from there. It does need to be symmetric in order for it to be properly accurate, yeah? What about the mean? Were there any restrictions on the mean? What do we notice? So have a look at the thing on the screen, okay? As soon as you start getting outliers introduced into your data set, the mean gets skewed towards it, okay? So the mean gets attracted towards outliers, okay? So if you have a lot of outliers in your data, and in fact you saw that on this, okay? You saw that on this. So for data set B and D, okay? So if you have a look here, for data set, C and D, you noticed that there were outliers in that data set. Like look at C. You had 1, 3, 2, 1, 1, 2, 1, 2, 2, and then you had a massive outlier at 55. So that was when the mean started to break down for that data set. That's the reason why we said the mean wasn't good for that data set, because it had an outlier. In other words, it got detracted towards it. Okay? Likewise with this one down here, like 1.9, 3 something, 2, 1, 0.1, then you had a massive number out here at 43.9. That's an outlier, and the mean got attracted towards that. Okay? So the mean always gets attracted towards outliers. So if you have outliers in your data set, you just got to be aware the mean will be attracted towards it, and you need to bear that in mind when you're choosing which measure of central tendency to use. Yes?
In other words, if that happens, so mean is not suitable for the
Yeah, exactly. The mean wouldn't be suitable in that case. So what I'm trying to get across here, the reason why there are 3 measures of central tendency, mode, median, and mean, is because each one would be useful for different situations. Each one would be useful for different situations.